This is a tutorial covering how to calculate the percentage uncertainty of a measurement. This topic is examined as part of AQA GCSE Chemistry and Combined Science, Unit 3. By the end of this video, you should be able to describe what is meant by uncertainty and calculate percentage uncertainty for sets of results. Whenever you make any measurement, there's some uncertainty associated with that measurement. In other words, the number you write down might not be the exact true value, even if that's what your scale said or what you read on your ruler. This could be for a few reasons. It might be the resolution of your equipment. This Satsuma probably has a mass somewhere between 90 and 91 grams, but the resolution of my scales, the smallest measurement that they can tell the difference between, is only 1 gram. So every measurement I make with my scales is only to the nearest gram, and it could be out by up to half a gram because it's always rounded up or rounded down. There are also lots of experiments where there isn't one true value. Say we want to measure the speed that somebody can run. They might run slightly differently each time that we test them, and so there's always some variation in the value because of that randomness. For this reason, it's really important that whenever we do a scientific experiment, we repeat it until we have enough data to conclusively say that the data are repeatable and the conclusion we're drawing is valid. This usually means repeating everything at least 3 times. This also allows us to identify anomalies. An anomaly is a result that doesn't fit the pattern of the rest of the data. So for instance, if I looked at these 6 pieces of data, here you can see that they're all quite similar values, except for 12 grams, which is clearly very, very different. That piece of data is called an anomaly, and when I go on to analyse my data, including calculating a range or a mean, I should always take out that anomaly first and not include it in any further calculations. Since my scales can only measure to the nearest gram, every measurement I make could be out by up to half a gram either way. That's what we call the absolute uncertainty, the actual difference between the measurement I make and the true value. I can show this with a little plus minus sign. This means that the true value could be 0.5 grams higher or lower than the mean that I'm reporting. How much that 0.5 grams matters is going to depend on what it is that I'm trying to measure. If I was trying to measure out 500 grams of flour, then being out by half a gram is not that big of a deal. But if I'm trying to add half a gram of salt to a recipe, then being out by half a gram could mean that I'm literally doubling the amount that I'm meant to be adding, and that's a huge difference. So when scientists are talking about how precise their data are, they use the term percentage uncertainty, and this gives us a better idea of whether our data are very, very accurate or whether there's quite a lot of uncertainty in there. To calculate percentage uncertainty, you divide the absolute uncertainty by the mean value, and then multiply this by 100 in order to turn it into a percentage. For most of the experiments that you'll do in school, the absolute uncertainty can be found by looking at the range and then halving this. If I want to work out the percentage uncertainty for these 6 pieces of data, the first thing I need to do is to check for any anomalies. Are there any pieces of data here that are so different from the others that I should just discard them and not include them in my calculations? In this example, I'm going to discard the second piece of data because it is so different that it will skew my results. My next step is to calculate the range. This is the largest result minus the smallest result, which in this instance gives me an answer of 7. Next, I need to work out the mean, and to do this I'm going to add together all 5 remaining pieces of data, and then I'm going to divide them by 5 because there are 5 pieces of data. So to show that I'm dividing all of them, I'm going to use brackets, and this gives me a mean of 28. And then to work out the percentage uncertainty, I'm going to take half of that range and divide it by the mean and multiply it by 100%, and that gives me a percentage uncertainty of 12.5%. Here's another set of data to practice doing the same calculation with. If we look at these data, we can see that the 4th one is a real outlier, and we discard this. Next, I work out the range by doing the largest number take away the smallest number, and that gives me a range of 3 kilograms. Then I work out a mean by adding them all together and then dividing them by 5 because there are 5 pieces of data remaining, and that gives me a mean of 15 kilograms. Then, to work out the percentage uncertainty, I do half the range divided by the mean times by 100 to give me an answer of 10%. That means that whenever I measure this value, my answer could be 10% too high or 10% too low. In other words, my data are not particularly accurate. Here are 8 data sets for you to practice calculating the percentage uncertainty. For each one, you need to first identify whether there are any anomalies that need removing, then calculate the range and the mean and use those together to calculate the percentage uncertainty. For the first data set, the largest number take away the smallest number gives us a range of 6. The mean of those data is 10, and therefore the uncertainty, which is going to be half of 6 divided by 10 and then turned into a percentage, is plus or minus 30%. For the second set of data, the largest number take away the smallest number gives us a range of 10, and the mean is 25, which gives us a percentage uncertainty of plus or minus 20%. In the third set of data, the largest number is 94.8 and the smallest number is 84.9, so that gives a range of 9.9 and the mean is 90, so that's plus or minus 5.5 percentage uncertainty. In set 4, we've got an anomaly, so we're not going to include that number 500 because it's much larger than the rest of them. Looking at the remaining data, my largest number take away my smallest number is 24, and the mean of those is 240. So that's a percentage uncertainty of plus or minus 5%. In set 5, the largest number take away the smallest number is 0.8, and the mean of these data is 2.5. So that's plus or minus 16% percentage uncertainty. And then in set 6, we've got another anomaly. This number is far smaller than the others, so there's obviously been some kind of error in the measurement here. So looking at the remaining data, the largest number is 56 and the smallest number is 44. So my range is going to be 12 and my mean is 50. And so that gives me a percentage uncertainty of plus or minus 12%. And then in set 7, 10.7, take away 9.3, it's going to give me a range of 1.4. The mean is going to be 10, and then that gives me a percentage uncertainty of plus or minus 7%. And then in our last data set, we're going to have a range of 2.6 and a mean of 41.6, and therefore a percentage uncertainty of plus or minus 3.125%. Thank you very much for watching, and I hope you're now feeling a little bit more confident about identifying anomalies, calculating absolute uncertainty, and then using that to calculate percentage uncertainty. If you did find this useful, then don't forget to like and subscribe for more GCSE Science revision videos coming soon.